Okay, now questions related to transformer. We'll do electromagnetic induction in transformer, but more mainly transformer. Transformer consists of two coils of wire wound on a core. Suggest the material from which the two coils are made and state the reason for using this material. Which material wires are made up of? The coil, the wires. No, that's wrong. The wire. Yeah, the wires are made up of copper. And why copper? Because copper is a because in the wire we want the current to pass. So if you want current to pass, we want a good conductor. So iron can also conduct, but copper is a good conductor. So these coils, these wires, which material these wires are made up of? It is made up of copper. And what is the reason? Because it can conduct electricity. The second part suggests the material from which the core is made, like which material this core is made up of. Yeah, this is made, the core is made up of iron. And reason, because it can easily magnetize or demagnetize. So it can easily magnetize and demagnetize. Now you can see the power station generating electricity. Then it is generating 22,000 volts. 22 kV means 22,000. Then using a transformer, the dot here represent like long distance between the wires, and transmitting to 132 kV. And then when we receive at home, they're supplying us 240. Why they're not giving us 130 kV or even 22 kV? That's too high voltage. So our devices are only calibrated or working efficiently around 240 volts. That's too high voltage for the devices to work. And even if someone will get an electric shock with about 132 kV or even 22 kV, likely he will die due to that shock. But 240, if for a short instant, if he like for a short time, if a person is electrocuted, then it cannot be fatal. But for a long time, even if it's 240 or 220, but if passes through a long time, then it can be fatal. Now, figure 8.1 represent a system of transmission of electrical energy from power station to a home that is a long distance away. State the difference between transformer X and transformer Y. What is the difference between transformer X and transformer Y? Okay, now what's the difference between transformer X? Transformer X is taking 22 kV and converting into 132 kV. So which transformer is this? Step up or step down?
Step up.
So transformer X is step up transformer, but Y is step down. I'm writing in short, but you will write in a sentence because you need a difference between them. Explain why a very high voltage is used for transmission over a large distance. So what is the reason for that? When we use a high voltage, it's of 3 marks. So I will show you the marking scheme as well. You can have an identification like the distribution of the mark. The reason to show the marking scheme so that you understand the distribution of the marks. This is February, March 2017 paper. So 1 mark, high voltage means there will be low current. So the power loss is less. And normally we have thin cables or wires which are suitable for low current. Like it cannot carry too high current. Comparison is there. So high voltage means low current output, which reduce the power loss due to heat, and this wire, normally the wires which you are using can easily carry low current. If it's too high current, the wires, because current is a flow of the charges, so wires are not able to carry that current from one place to another. The next part suggests why the voltage for use by a home consumer is 240, not much higher value. What's the reason? Yeah, for safety, or you can see 240 is a safe or a safer voltage for the consumer, because if it's too high voltage, that it might be fatal. Yes, step down current is increased. Step down transformer voltage decrease, current increases. But what affects is the power remains same. Okay, next question. This is about electromagnetic induction. And the next question is about transformer. So in this question, figure 10.1 shows a straight wire AB placed in a magnetic field between the poles. The end AB are connected to a galvanometer. The wire AB is moved vertically. The needle of a galvanometer show a deflection. State 3 factors that affects the size of a deflection, like whether it will deflect more or less. What factors affects the size of the deflection? Yeah, the speed, basically the force, the speed at which we are moving the wire. If we are the force is greater, so the greater acceleration. The size of AB as well, like length of AB, length of a wire in a magnetic field, and the strength of the magnetic field. So speed, the speed, if you change the speed, there's a change in magnetic field, greater change, greater induced EMF. The size, the length of a wire in a magnetic field, that also affects the higher induced or lower induced current or voltage. And the third factor, the strength of the magnetic field. These are the factors which affect the induced EMF. The next question, first thing, which transformer is this? Step up or step down? Which one it looks?
Step down.
Step down, because you can clearly see input is 240 and output is only 12. So it's a step down transformer. Now in the question they said the this figure 10.2 shows a transformer. The primary is having 8,000 turns. So NP is 8,000. Input, so VP is 240. The secondary VS is 12. Calculate the number of turns. The formula which relate the number of turns and voltage is VS over VP, means voltage of secondary divided by voltage of
Over.
primary is equals to number of turns of secondary divided by number of turns of primary. Just substitute the values. So voltage of secondary, we know it's 12. Voltage of primary, it's 240. Number of turns of secondary, we don't know. And number of turns of primary are given 8,000. So 8,000 is divided, other side it will be multiplied. So it will be 12 multiplied by 8,000 divided by 240. This 0 will cancel with 0. This will be 12, 2. This will be 2 and
400.
400. So this will have 400 turns, NS. Is it clear? Just the formula, direct formula, and you can work out the number of turns. The next part, the current containing a resistor is connected to terminal AB. A direct DC is required. Actually, that's related to circuit components that we will discuss. Because if a transformer input is AC, the output is also AC. So it will be 12 volt AC. And there's a component which can be used to convert AC to DC that we will discuss in a circuit component. That's why I'm not answering the next part. Another question, electrical energy produces by power station is transmitted over a long distance at a very high voltage. Why a high voltage is used? What's the reason?
The same answer.
It's the same answer, because increasing a voltage reduces the current, reduce the power loss or heat loss or energy loss, reduce the power loss in the form of heat or energy lost in the form of heat, and low current. The wires also, the high transmission wires also, they are thin, so they are not able to carry too high currents. The same answer, I'm not typing it again. The next, again you can see it's a step down transformer. A 12 volt input is there, so VP is equals to 12. Vs is equals to 9. Number of turns of secondary 4,000. You need number of turns of primary 4,000. You need number of turns of secondary. Again the same formula, which is Vs over Vp equals Ns over Np. Voltage of secondary 9, voltage of primary 12. Sorry, 120, not 12. Number of turns of secondary we don't know, and number of turns of primary 4,000. So 4,000 is divided, other side it will be multiplied, so it will be 9 multiplied by 4,000 divided by 120. This 0 will cancel with 0. This will be 3, this will be 4, 1, 100, so it will be 300 turns. So you will write 300. There's the number, there is no unit, because it's a number like 300 turns or 500 turns. Next, state the suitable material for the core of a transformer. Which material this core should be made up of? So it is made up of iron. That's right. A transformer is needed to step down 240 volts to 12 volt AC. In a space below, draw label diagram of a transformer. So it's the same one that the previous figure, how it was shown. So same way you will draw. that a soft iron core, it's up to you. One side will be primary, and it's not like you should make a count the number of turns, but it should be visible that which side is having more turns and which side is having few turns or less turns. So this is AC supply. It should be labeled like I should label the primary coil, supply, iron core, secondary coil. I should label all these points. It's of 3 marks. Why transformer only work with AC? What's the reason? Why a transformer only work with AC? Why not DC? Yeah, because AC current produce variable magnetic field or change in magnetic field. So DC, or you can write other way around, you can mention direct current does not produce change in magnetic field. How input voltage is changed into output voltage? So basically you have to write a working of a transformer here, that AC input magnetize, AC input in the primary produce variable magnetic field which magnetize the iron core. The change in the magnetic field of iron core induce EMF in the secondary coil. Use a ruler, proper, it should be neat drawing for this transformer, not a rough, because if you see the mark, that it's of 3 marks. So that's why rough diagrams are not acceptable here. It should be proper diagram. Then the output current is 1.5 ampere. What is the output power? So output current is there and output voltage is there. So this is the output voltage, and we know the output current is 1.5. So what is the output power? As we know, the power is a product of voltage and current. So P is equals to V I. But in this case, output will be voltage of secondary, current of secondary. Voltage 12, current is 1.5. So 12 into 1.5, that's equal to 18 watts. So the output of this transformer is only 18 watts. And energy supplied in 30 seconds. So energy supplied in 30, energy is power multiplied by time. So 18 multiplied by 30, 8 multiplied by 3, 54. So that will be 540 joules. Another question. The transformer in the figure is used to convert a 240 volt AC to 6 volts AC. Use information, calculate the number of turns of the secondary. What's the answer? for secondary turns? Yeah, that's right. This one is VP, VS, NP. You need NS. So VS over VP. The formula is VS over VP is equals to NS over NP. Voltage of secondary is how much? It's 6. Voltage of primary is 240. Number of turns of secondary we don't know. Number of turns of primary 480. 480 will be multiplied. So 6 multiplied by 480 divided by 240. So when you solve, this will be 2. So 2 multiplied by 6, that's equal to 12. So NS is equals to 12 turns. Describe how the transformer works. The same thing. AC input in the primary produce variable magnetic field. This magnetic field magnetize the iron core. Change in the magnetic field of iron core induce EMF in the secondary. State one way in which energy is lost from the transformer and from which part? From where energy can be lost? Energy can be lost in the form of heat and secondary, primary, both. Even in a primary, there is a heat loss and the coil or the wire in the form of heat. Yes, so you can mention wire and how it is lost in the form of heat. This is about electromagnetic induction. The next part is related to transformer. Figure 8.1 shows a bar magnet suspended by a spring over a coil. The coil is connected to a sensitive 0 voltmeter, means the needle is at 0 mark. The lower end is pushed down into the upper end of a coil. During the movement, EMF is induced and the needle is deflected towards right and then returned to 0. Why this is induced EMF? Why explain why this EMF is induced? Because when we move the magnet, there is a change in the magnetic field that cause EMF to induce. Yeah, due to change. In short, it's a 1 mark, so you can mention due to change in magnetic field. What happened to the needle of the meter when the magnet is released from rest and pulled up? So if it is released from the rest and it is pulled up, means moving up. Which direction the needle will deflect? When it was coming down, the needle was deflected towards right. Now it's going up. So needle will deflect in opposite direction or anti-clockwise. The magnet is continue to oscillate up and down. If magnet is moving up and down, what we will observe about the deflection of the needle? So the needle will also deflect right and left. Now this is a question related to a transformer. What's the answer? You already did a lot of questions, similar questions. So I want you to tell the answer. Solve this. Primary, secondary. Yeah, that's right. So Vs over Vp is equals to Ns over Np. $200 turns will be there because we have Vs over Vp equals Ns over Np. Vs is given 6, Vp is given 240, and Ns we don't know, and Np is given 8,000. This 8,000 is multiplied with 6, so divided by 240, we will get our final answer as 200 turns. The current in the primary is 0.05 ampere. Calculate the power input. So how to calculate a power input? The current is there 0.05. What is the power input? Power is a product of voltage and current. So multiply the voltage with the current. So 240 into 12 into 0.05, that will give 12. So the input power is 12 watt. And if transformer is 100% efficient, then output power will also be 12 watt. If it is 100% efficient, practically it's not possible, theoretically 100% efficient. Now 90% of the input power, so they give you a practical question, 90% of the power input is transformed and transferred to the lamp. Calculate the current. So first, if this transformer is not 100% efficient, so first we need an output power. So how to get an output power? We have the formula, efficiency is equals to power output over power input multiplied by 100. So this is 90% efficient. Power input it's 12, power output we don't know, multiplied by 100. Cross multiply, so power output will be 12 divided by 90 multiplied by 100. What's the answer? For power output it's 10.8. What's the answer? 13.3. Okay, so it's 13.3 watts. 13.33 is a power, but in the question we don't need power. So we need a current. So 13.33 is a power, and voltage of the lamp is 6. So we need a current. So 6 is multiplied, other side divide. 13.3 divided by 6. What's the answer for current? 2.21, 2.22, 2.21 or 22 amperes. Is it clear? If you are taking all the number, like if it's 13.3333, then it will be 2.22. But both are right answers. It depends on how many numbers you took for in the calculator to get the final answer. Is it clear, this part? Because this transformer is not 100% efficient, that's why the power output and the power inputs are not same. So we have to use the formula for efficiency. If there was no loss, like if it was 100% efficient, if there was no loss, then we will use the same value. Another question. Figure 8.2 shows a DC supply is connected to input of a transformer. When a switch is closed, the needle of a galvanometer deflect briefly, then return to zero. Explain why the brief deflection occur. It's a DC supply. So when we close the switch, the moment, because what happened when the switch is open, there is no current. But the moment when we close the switch, we connect the switch, now there is a current, but that's not a current, constant current. The current is changing. And then the current will be constant. Even this is not a practical, this is also theoretical. Practically, you know what happened when we close the switch? This is how the current changes. When we close, even normal switches increases and then it becomes good. This is practically what happened. Because when you connect the switch, practically the resistance of a circuit is too low in the beginning. That's why maximum current. And then when the resistance is constant, the constant current flow through the component. So this part, so when we close the switch, there is a small change in magnetic field. So magnetic field produced by, for a change in the magnetic field when the current, when the switch is closed. For short instant, so when switch is closed, it produces change in current for short time, which changes the magnetic field and induce EMF. Explain why the voltage of a supply to the primary coil of a transformer must be alternating. Why it cannot be DC? Why it must be alternating?
To produce a magnetic field
The magnetic field will be produced by even by DC, but why?
continuously, yeah.
So why it should be AC, not DC? DC is also producing a magnetic field. AC is also producing a magnetic field. Both produce magnetic field. But why it must be AC, not DC? That's a question. Yeah, AC produce a constant change in magnetic field, a continuous change in magnetic field. So to produce an alternate or change in magnetic field so that the current is induced continuously in the secondary. Otherwise, if we use a DC and for a short instant we close the switch, so it will produce EMF only for that short instant. Figure 10.1 shows a transformer. There are 800 turns in the primary. Main supply VP. Voltage of secondary is 6. The question is how many turns of secondary are there? NS. Already did this same values. There was a question with the same values exactly. What's the answer? So it will be 200. That's right. So VS over VP equals NS over NP. The current in the lamp is 2 ampere. The transformer operate with 100% efficiency. Calculate current in the primary. The current in the lamp, we know the output voltage is 6. That's given. So Vs is given. And the current in the lamp is also given in this part 2 ampere. So we need current in the primary, current in the fuse or current in the primary. So we know the if it's 100%, that they mentioned the transformer is 100% efficient. So it means the power input and power output will be same if it's 100% efficient. The input power of a transformer equal to the output power. The input power is the voltage of primary, current of primary, and output power is voltage of secondary and current of secondary. So voltage of primary is 240, current of the primary we don't know, voltage of secondary is 6, and the current in the secondary is 2. So what is the current in the primary? It will be 6 multiplied by 2, that's 12, and then 240 is multiplied, other side it will be divided. 12 divided by 240, what's the answer? No, it's 12 divided by 200, not, or you did opposite. Yeah, it's 0.05. So 0.05 amperes. That is a current which will flow through this primary. The primary contain a fuse of 2 ampere. Okay, leave this part. Reason for that, because you can use the understanding, because a primary fuse, what is a fuse actually? It's a 1 mark, that's why I'm explaining. Otherwise the fuse part in a circuit component I'll explain. Look, a fuse, what is a simple fuse? A fuse consists of a metal wire, and this metal wire, because of the heat, when the current is passing, it produces heat, and this heat melts the fuse. So every fuse is having its own rating. Like example, if this fuse rating is 2 ampere, it means it can allow 2 ampere to pass. If there is more than 2 ampere, it does not allow it to pass. So what was the current here? 0.05. When one lamp is connected, the current is 0.05. How many lamps we can connect before the fuse will blow? So for one lamp, you can use a lamp, because we want the current. We want to find when current is 2 ampere, how many lamps will be there? It will be 40 lamps, because if one lamp is allowing 0.05, so if 2 ampere, how many lamps will be there? X. Cross multiply. So you will get 40 lamps in this. So 40 lamps can be connected before the, if it's more than 40, the current will be more. So yes, you can use a ratio here to identify how many lamps can be connected. Basically, when one lamp is connected to a fuse, when one lamp is connected, it was allowing 0.05, or it needs 0.05. But how many lamps should be connected so that the current in the fuse will be 2 before it melts? So fuse will melt after 2 ampere. So these are the questions related to transformer. Any doubt related to this part, the transformer? So tomorrow, magnetism, last topic of magnetism we'll do. Electricity is still circuit component left, but magnetism will do AC generator, and then the electricity circuit components. So I'll end the session and share the recording with you.